Welcome to this explainer. Okay, picture this. You're looking at a massive bridge, one that plunges straight through the open ocean, and you're probably thinking, how on earth did they actually pull that off? Well, today, we're decoding the awe-inspiring engineering behind massive water bridges. We're going to look at the exact science and construction methods that allow humans to literally conquer rivers and oceans. We've all seen them, right? These crazy structures spanning across rushing rivers or just slicing right through the middle of the deep sea. But honestly, how do millions of tons of steel, solid concrete, and the weight of heavy speeding vehicles just safely float above the water without sinking straight to the bottom? I mean, it kind of feels like impossible magic, but it's not. It is pure, incredibly precise engineering. So here is our agenda for today's explainer. 1. The mystery of water bridges. 2. The biggest challenge, foundation. 3. Cofferdam, dry space in water. 4. Deep sea construction. 5. The bridge's superstructure. And finally, 6. The Bandra-Worli Sea Link. Let's jump right into Section 1, the mystery of water bridges, building the impossible over water. You know, these bridges are absolutely vital lifelines for isolated areas, saving us tons of time and fuel. But why don't they just collapse? Well, here is the secret. Millions of tons of weight are safely transferred directly to solid ground. Yep, the load of 1,000 rush-hour cars is continuously channeled straight down, through those mighty pillars, deep into the earth. The water isn't actually holding the bridge up at all. The solid bedrock is. Moving to Section 2. The biggest challenge, foundation. Battling gravity, water, and mud. Now, to keep that foundation absolutely flawless, engineers definitely can't just guess. Before a single drop of concrete is even poured, they face this high-stakes mathematical puzzle. They've got to calculate the maximum and minimum water depth, figure out the exact speed of the water flow, rigorously test the soil condition beneath the water, and, of course, factor in the total weight of running vehicles. Literally one math error here, and the whole thing comes down. Okay, Section 3. Cofferdam, dry space in water. The shallowed river solution. So think about it. If you can't build your foundation while it's underwater, what do? Well, you just push the water away. Enter the cofferdam. It's basically a temporary structure made of these really long steel plates, usually built in a circle or square, and it's used to pump out water to create a totally dry work environment. Engineers literally build an empty, dry room right in the middle of a rushing river. Let's look at how this wizardry actually works, step by step. First, you build the steel structure. Second, you sink it super carefully into the water. Third, you bring in the heavy-duty motors and pump all that trapped water out. And finally, step 4, you build the pillar right there in the dry space. It's a real game changer. It takes a chaotic, moving river and turns it into a highly controlled workspace. And it gets wilder. Sometimes floating cofferdams are used, and these can actually be moved by ships and rotated into place by highly professional engineers. It's incredibly dangerous work, for sure. You really need elite professionals handling this, because out there in a rushing river, an amateur mistake would be absolutely fatal. All right, Section 4, deep sea construction, when cofferdams aren't enough. See, out in the open sea, the water is just way too deep for a standard cofferdam, so we have to contrast the two. River construction uses those temporary dry spaces, like we just talked about. But deep sea construction, that requires a totally different beast, direct seabed drilling and heavy iron pipes. You just can't fight the deep ocean the exact same way you fight a shallow river. To conquer the ocean, they have to follow a really intense process. Step 1, locate the absolute strongest point on the seabed. Step 2, drill massive holes down there using heavy machinery. Step 3, insert these incredibly heavy iron pipes directly into those holes. And Step 4, pump out the water from inside the pipes and fill them with a super strong concrete mix. So an incredibly solid pillar is quite literally born from a hollow pipe deep underwater. Moving on up to Section 5, the bridge's superstructure. Assembling the massive top puzzle. Okay, so once our foundation is rock solid, we can finally look up. And here's the crazy part about bringing the top together. Massive concrete blocks are actually prefabricated far away in factories. Then they're transported over the water by gigantic ships, lifted high into the air by massive cranes, and assembled step by step onto the pillars. It's literally like snapping together giant floating Lego blocks right in the middle of the sky. Finally, Section 6. The Bandra-Worli Sea Link, a real-world triumph in Mumbai. When all this intense engineering comes together perfectly, you get absolute marvels like this one. It spans a whopping 5.6 kilometers. 5.6 kilometers straight across the open sea. It's a towering monument to what human ingenuity can actually achieve. And it didn't happen overnight. It took 11 years of relentless, difficult work. That's 11 years of expert engineers and construction workers battling a harsh marine environment just to make this deep-sea marvel a reality. To put this scale into perspective, it was completed at an estimated cost of nearly 1.75 lakh crore rupees. And honestly, standing as an excellent specimen of engineering, that astronomical budget tells you exactly why the math we talked about earlier has to be absolutely flawless. There is zero room for error out there. So, next time you travel across a water bridge, take a second to look down. Will you appreciate the invisible engineering hidden beneath the waves? Every single time you safely cross, you're riding on the back of relentless scientific calculation and bravery. I really hope this explainer gave you a totally new lens for the everyday marvels around you. Make sure to share this explainer with someone to help them see the world a little differently. And as always, keep learning.